Welcome to the STEM Pathways with Rohan Sharma podcast, where we dive into the exciting world of science, technology, engineering, and math. In each episode, we share exciting stories, groundbreaking research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we explore the endless possibilities of STEM. Let's get started. Today, I'll be interviewing Zachary Ellis, who's currently a Ph.D. student at Georgia Tech. How are you doing today?
I'm doing great. How are you?
I'm doing good, and thanks for coming on the podcast. So, to get started, I wanted to ask you about your interest back in high school and what made you choose your major for your undergrad.
Sure. I think I've always been pretty interested in engineering. I think like a lot of younger kids who have that sort of interest, I was always like building things at home. Like for every birthday, Christmas, like building Legos, taking things apart in my house and trying to put them back together. And particularly, I always had an interest in cars. So I thought, what can I do to help me, work at these car companies that I'm so interested in? And I landed on engineering. I originally thought I might do mechanical engineering. I ended up switching to electrical, but um, that was why I got started.
Yeah. So, what was your experience like at Purdue?
Yeah, so I think Purdue is a pretty interesting school. I think that their system really helps people get like understand what they really want to be as an engineer. So for those of you who aren't familiar, like when you apply to Purdue for engineering, you just apply for engineering. You're not in a specific major, and then throughout your freshman year, you actually get to learn about the different engineering majors and then apply to your specific major at the end of the year. I really found through like that exploration process that ECE was a better fit for me compared to maybe mechanical engineering. And then also when I was at Purdue, I joined our electric racing team, Purdue Electric Racing, and through working on our car and getting a lot of hands-on experience, I came to know like what I liked, some things that maybe I wasn't as that I didn't think I liked as much as I might have thought I would. And so I thought that just having a really large school like that with a lot of opportunities was really great for me personally.
Yeah. So, when did you decide that you wanted to go on and go to grad school?
I think it was in like around my junior year, like later in my junior year. Um, while I was at Purdue, I took a class called ECE 337, which is our like one of our digital design courses, where we learn about designing chips, where we learn about the process of actually making like digital hardware on a large scale. And prior to that, I really thought I was interested in the automotive industry, and I'd done some prior internships in automotive companies. But I found that I actually really loved the stuff that we did in that class. And I got to talking to more of the TAs, to the professor, and I realized, if I want to really follow this career path, then grad school is probably the best choice for me.
Yeah. So, what's your research about right now?
Yeah, so I currently research hardware security. I research a specific type of physical attacks called side channel attacks. The idea behind this is that if you're doing processing on secret information on a chip, the secret information on the device, may be leaked out of the device through unintended means. So, for example, you might be able to measure the power consumption of your CPU and be able to tell based on that what data it's operating on. So I work on ways how we can better understand how this actual information is leaking out through these unintended means, how we can prevent it, and how we can study it.
Yeah. So, when you got to Georgia Tech, what was the process for kind of choosing what you'd be researching?
I did a little bit of undergraduate research when I was at Purdue, and I was working on actually an entirely different topic. I had reached out through the grad application process. I had reached out to a lot of different professors at different schools, and had found a good fit with my current advisor, Professor Arjit Raychaudhuri, who was working on some of the stuff that I was working on at Purdue, which was more like machine learning acceleration. He'd introduced to me the idea of working on a hardware security project that I found really interesting, and I decided to um, go through with it from there. I worked with a more senior PhD student at first who really taught me a lot about the topic and sort of showed me the ropes.
Yeah. So, some big thing that you started outside of your PhD was SiliconJackets. Can you give like a brief summary of what that is?
Yeah, so SiliconJackets is a student-run chip design group. We are like many of the other engineering-based project teams that you might have at your university. So, like for example, at Purdue, I was on Purdue Electric Racing. You may have a solar car team or a rocket team. SiliconJackets is very similar to that, except our end goal is to produce a chip. So we're currently working on the second iteration of our RISC-V CPU, and we're at around 100 members.
Yeah. So, what are kind of like the steps from start to finish to make a chip?
Yeah, so generally, it depends what chip you're making, but for SiliconJackets, for simplicity, we're purely focusing on digital designs. So when I say digital, I mean things like, the tip that goes in your phone that's doing calculations with ones and zeros. And so at first, you really want to make a plan. I think it's really important to plan out exactly what you're going to do before you do it, especially with the number of students that we have involved in the project. We then will create the design in a specialized language called Verilog, which is called a hardware description language. So it's a little bit different than a typical programming language where instead of things happening line by line, it actually gets compiled into hardware. With that description of the hardware we want to make, we use a set of tools that are used commercially in industry to turn that into um, a physical design on the like logic gate level, which can then get manufactured by something like TSMC, or we use Skywater foundries for our chips.
Yeah. So, how long does the process take?
So we aim to do a new chip once a year. It's a very involved process. Creating chips can be very difficult. Each chip may have millions or more individual like logic gates or components. And so we do a lot of work on the design, but we do just as much or more of work on simulating our design, verifying it, and making sure that when it gets put all together, it has a high chance of working. So I would say a year is our time frame.
So, I was looking through your website and saw that you have some sub teams, and then obviously you have over 100 members. As kind of the leader of the whole thing, how are you able to organize this many people, get them split up, and make sure that each sub team is doing what they need to do?
Yeah, so I'm really thankful that I had the experience at Purdue of being part of a successful project team that had a similar structure. SiliconJackets borrows a lot of the structure of our team from Purdue Electric Racing and from the structure of, I'm sure, many other project-based teams at other universities. I think what was important for me was to sort of shorten the chain between the people who are working on stuff and the people who are sort of organizing. We only have like one level of hierarchy between like the leads and like the president or vice president. And so I think that it's really important to move slowly. If you're creating something new like this, move slowly, keep your scope very small, and just do a lot of planning up front. I think if you have a plan in place and you give people really clear directions, it can be less difficult to scale beyond a large group of people.
Yeah. So, what kind of crowd are you attracting for the members? Is it mostly upperclassmen or underclassmen able to be involved as well?
Yeah, so I think what's really important to me, or what was really important to me and my co-founder Nielsen Lee, who I started the club with, I think what was really important to us was not to limit the people who were coming into the club based on prior experience, but rather enthusiasm. From my like past experience working on like the racing team, and just like other like projects like that, I have learned not to underestimate people who are just coming in. And so, in fact, actually, a large portion of SiliconJackets is freshmen and sophomores, and some of them have been able to do some really great things, and some of them are even turning into leaders in the club. So I would say about half is freshman, sophomore, and then probably 25% upperclassmen and another 25% grad would be the makeup that we have.
Yeah. So, outside of your education, I saw that you've done multiple internships. Can you talk a bit about those?
Yeah, so I lost count of how many I've done because I've been in school for a while. But I think doing internships is a really, really important part of your education, especially like doing practical things like engineering. And I think that you should, take every opportunity you can to apply your skills practically. And I think even when you're in school, doing practical things like SiliconJackets or another team really helps you stand out. But in terms of my internships, I learned a lot about not only how to be a good engineer, the processes of doing engineering work and being methodical and patient and calm, but also like what do I actually like to do? As I said before, like I originally thought I wanted to work in the automotive industry, and I had some really great experiences working at a couple different companies in that area. But I learned that it really just wasn't for me, and the process of doing chip design was more what I was interested in. And so doing internships throughout my undergrad and grad degree really helped me hone in on what I actually wanted to do, and it's helped me sort of get myself in the place that I want to be in for when I, finally move on to being a full-time in the workforce.
Yeah. So, I guess as a freshman in college myself, I was wondering what your first internship felt like and what it was like to like suddenly have a real job for the first time.
Yeah, I mean, I think it was crazy. So my first internship was at a smaller company called E-Controls, which is based out of San Antonio, Texas. I think it was a really great opportunity for me because I was paired up one-on-one with an engineer who was really experienced and, was helping to build a new line of products. And so got a lot of great hands-on experience, just like getting stuff done. But I think that for someone new to this, your confidence is really important. I wouldn't be overconfident. I wouldn't, think that you know everything, but having the confidence to try things is really important. I think if you go to your internship timid that you're going to mess up, and try to be safe, you're not going to learn as much. At my first internship, I spent a long time designing a circuit board, and we got it back, and like a large part of it didn't work. And from that, I learned like a ton of things. I learned exactly like what I did in my design process that sort of prevented me from creating a successful product. I missed checking some things that caused my board to be like really cumbersome to assemble and work with. And I think through those are some of the best experiences for helping you become a better engineer. I think every mistake I've made has added a like item to the checklist in my mind when I do something, which says like, make sure you don't forget to do this thing. So my advice for someone who is just starting out or is just getting their first internship is like, be willing to try things, be willing to like fail and like go to your boss and be like, hey, I messed up. What should I do? What do you think? And just take your time to learn as much as you can while you're there.
Yeah. So, I saw on your LinkedIn that you're kind of getting close to the end of your PhD. Do you know what you want to do next? Are you going to go into industry or academia?
So my plan is to go to industry, back to the team that I was working at Apple. So as I mentioned before, like in my research, I'm researching hardware security. At Apple, like in broad terms, what I was working on is helping to improve the efficiency of the chips that Apple produces. This may seem like something that's not really related to my research, but actually a lot of the techniques used to reduce power consumption to make things more efficient are similar to what I'm doing on a circuits level in my research. I think it's actually a very good fit. I think it really depends on, what your interests are. Doing a PhD or doing a grad degree can mean different things to different people, but I think it really helped me hone in what I wanted to do, and help me understand like how I can have an impact in industry at a high level.
Yeah. So, during your internship at Apple, I know that this is one of those companies everyone kind of puts on a pedestal and like hopes to be able to work out one day. Oh, what was your experience working there and how did it compare to some of the other internships you've had?
Yeah, I mean, I think in some ways Apple is very similar to other companies, and in some ways they're very different. I think that one thing I notice in particular about Apple is they're very committed to a couple core ideas. So working on the power team, I can say that like Apple is obsessed with like making efficient products and doing everything they can to squeeze the most efficiency they can about out of their products. They're obsessed with security, and there's a couple things that they really, really stress all the time. I think that of all the companies I've worked at, the ones that have felt the most put together have had these core ideas. Like E-Controls I worked at for my first internship essentially had these like five main mantras that they live by. And I think that kept everyone focused. Sometimes you would sort of meme on it. You'd be like, always do better or whatever. But I think having these core identities and sticking to them and being kind of rigid, as bad as it sounds, is actually good. In other ways, I think, Apple is filled with, and I think all these big tech companies are filled with people that are just people, they're smart people. They do good work, but they're not mythical. And I think if you get a chance to work there, just treat them like anyone else, try to learn from them and try to figure out why the things that they do work, would be my advice.
Yeah. So for my last question, I wanted to ask if you have one piece of advice for someone who's still in high school or early in college wanting to follow a similar career path as you.
Yeah, I mean, I think that my advice would always just be to build things. Personally, I've always really enjoyed building things. And I think that's why so far, like I've been successful in doing the things that I want to do as an engineer. If you do not enjoy creating things, debugging things, working through problems, then engineering will be difficult for you. And, it may not be something that you want to pursue. I think if you're in high school and you have an interest in something you want to do in college, do not wait. Just try to do something on your own. It doesn't have to be big. When I was in high school, I was just like, you know, trying to 3D print things, trying to like cobble things together with like a screwdriver, just whatever you have, try to do something with it. And I think that'll give you a lot of information about whether it's something that you want to pursue in the future and what you enjoy and really give you a leg up on the other people who are just waiting to get started.
All right, then. Thank you for joining me on the podcast today.
Yeah, awesome. Yeah, great to meet you.